here. All right, so as of right now, we have the ability to walk through. Here's 32 rooms. We have 16 treasures, so about half the rooms have treasures in it. That seems about right. We can walk through and try to collect all the treasures. We beat a level, beat a cave, if you will, if we've collected all the treasures in that cave. Now, how many moves should we let them have?
Moves for what?
Well, like for instance, so I have 32 rooms. I'm trying to collect 16 treasures. If we just let them keep going forever, then they
maybe 75% of the whatever rooms it is.
75% of how many rooms?
Yeah, we can have like few. 16 moves for like 16 treasures.
I think that'd be pretty hard. I really think it should be higher. I think it should be at least the same number of rooms, if not like twice the rooms.
Oh, then
yeah, it will be 32.
So let's try it with 32. So we need to then count down. We need to have moves left. So we're going to build into our stats another variable. Private static int moves left. Moves left will start off equal to 0. We don't have any moves left. Now, every single time, actually we'll start off as 1, same as num rooms. Every single time we add a room, we'll also add to moves left. So at the end, moves left will be the number of rooms. Well, let's make it equal for right now. Okay?
Every time the rooms would be...
Every time we add a room, we're also increasing moves left by 1.
Okay.
So our initial attempt here is if we have 32 rooms, there should be 32 moves to collect all the treasure. Make sense?
How about count down then?
Okay. Now, we're going to say public static int get moves left. How many moves do we have left? Well, we need to return moves left here. But every single time we make a move, we need to subtract 1 from moves left. So we're going to say public static void make move. We will call this every time we make something that is considered a move. Okay? And we'll say moves left minus minus. So every single time we call the make move method, we'll subtract 1 from moves left. Then we can also ask, how many moves left do we have? Okay? So we've just added some things to our stats to be able to handle this.
Make move would be counting minus minus, right? Move
Yep.
left. Okay.
So now we're going to go into our room. This is a move, correct? Every time we get the input successfully, that's considered a move, is it not?
Mm-hmm.
So we'll say stats dot make move every single time we make a move. Now, when we first visit a room, we're giving it the rooms treasure remaining, but we're also going to give it the moves remaining. Stats dot get moves left. So we'll print out moves remaining and we'll print out treasure remaining. Make sense? Then every single time we make a move, moves remaining should go down by 1. Okay. Now, let's go ahead and run this. We have 38 rooms, 17 total treasures. So this is giving us our initial starting point. We actually don't even need to say that because it says it right at the beginning of our game. So actually, let me just come out here. I'll get rid of these 2 lines. It's kind of redundant right now. All right, so moves remaining 39, treasures remaining 20. All right, so we're in a room, no treasures in this room. We only have 1 exit. Let's go 0. Moves remaining 38, still 20 treasures. Go to 0, 37, 19 treasures. Let's go to 0.
It means we have 39 rooms already, right? So it doesn't show up.
Well, we started off with a number of total rooms, but now I have 33 moves left and still 17 treasures. I'm out of exits. I got to go back to the beginning. That counted as a move. Okay, let's go to 0, 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 go to 0. Oh my gosh. At 24 moves remaining, still have 16 treasures.
Yeah, but like end of the day we'll get like more treasures.
There's a pot of gold. All right, 0, 0, 1, 0. Oh man, I think I just went the same way. 0, 0, 0, 0, 0, 1. Oh my gosh. 7 moves remaining, 15 treasures. This is not going well. Doesn't this feel just like Candy Crush?
Not yet.
I have 6 moves left, and I still have 15 treasures. Aren't there points in Candy Crush where like there's no possible way I'm going to be able to finish this? That's when you just quit.
Yeah, if you got like pot of gold, you might add them. 2, 3 moves.
Okay, maybe you do that.
Yeah, so
Every time you get a pot of gold, it's a free move. Doesn't count as a move or something like that. Okay. Okay, so in any case, we can mess around with the game mechanic, but this is a reasonable mechanic, correct? Okay. Now, we want to have a, we want it to yell at us when we've run out of moves. Similarly, we want to when we quit, it should tell us our statistics for the game. If we run out of moves, it should tell us the statistics for the game. That make sense? All right, so we already have it working for quitting. That's if we do this right here. It spits out statistics. All right. Now, what we're going to do is we're going to create a game over function. So game over is going to spit out game over, and then it's going to say how many rooms you visited, how many treasures you found, and how many moves left you have.
you making game over.
Okay. So that's what game over looks like in our current game. Now, when we quit, we'll just call this dot game over. Similarly, what happens when we run out of moves? When we run out of moves, we're not going to let them play anymore, right? They're done. Give them a game over. So we show them moves remaining. As soon as they make a move, if moves remaining is equal to 0, then we'll call game over and we'll return.
Yeah, instead of game over, like we can start again. We can begin the.
Potentially, yeah. But for right now, we're going to say game over.
So
All
you're
right.
printing out again, like at the end.
This happens when they quit or when they run out of moves. When they run out of moves, we detect it inside of our enter method. If moves left is 0, that means they're not allowed to make another move. Therefore, we'll say game over, and then we return. This is an important thing right here. Notice that the enter method does not return anything. It's a void. The return keyword makes a method immediately end. Since this guy does not return anything, we do not have return. We don't have a value after return. We can still use the return keyword to make this method end. Okay? So return without any value does not return a value, so it would be compatible with the returning void, but it does make the method immediately end. All right? So that's how we handle number of moves. Okay. Let's go ahead and run this again. 21 rooms, 11 treasures remaining. Ah, we already got a first pot of gold, so let's go 0. Let's go 0. Let's go 0. Stick with the 0. Stick with the 0. Okay, hit the base. Okay, now we're going to go 0, 0, 0, 1, 0, 0. Okay, I have 8 moves remaining, 5 treasures.
0.
It's getting kind of close now, right? 0, 0, 0, 0, 1. Yay. 2 moves left. Dead.
1. I gotta go.
I visited 21 rooms. I found 8 treasures. 0 rooms remaining. I probably should print out treasures remaining as well, right? How many treasures I left behind. Okay. It's kind of hard, a hard game. It's like a memory game, isn't it? It is kind of fun. Okay. So let's go back into our room. And let's do treasure remaining. That's this line. Okay. All right. So now let's go back into driver. let's make our cave size smaller. Let's shoot for 7. Okay. Now, could this number have come back as 600 or something? Certainly
Of
could.
course.
It just generates it until it hits something that's at least 7. 6 treasures. 0, 0, 0, back 0, 1, 0, back 0, 1. I'm already out of turns. This game is impossible.
3. Oh, there was 6 treasures in there.
So you're arguing that maybe when we find a treasure, we add a move?
Maybe
That's part of the
2.
treasure, because you get an
Maybe
extra
2
move?
Not adding 2 moves if you find that.
Well, or what we can do is inside stats here. Maybe the number of moves is always equal to twice the number of rooms.
Oh yeah, that would be more. Like if there's 7, there'll be 14 moves.
Right.
Okay.
So let's try that. Let's see if that's more. Oh, 65. Okay. Zero. 0, 0, 0, 0, 0, 0, 0, 0, 0. Oh my gosh. Oh my gosh, so close. Man, it's impossible.
What you got?
1 move remaining, still 4 treasures. It was a hard game.
Created a monster.
We did. Okay. Now, when you play a game like this, you probably want to have multiple levels, correct? Now, what if we wanted, when we passed in a 7, that wasn't the maximum size of the grid. Instead, it was the size of the cave. So we want to generate a cave until we get a cave with 7 rooms in it. Exactly 7 rooms. This would allow us to have some kind of like increasing difficulty, right? As it is right now, level 1 might have 80 rooms in it. So how would I modify my code so that minimum number of rooms is no longer minimum number of rooms, and instead it's
Level 1.
number of rooms? I don't want to do it until it's less than. I want to do it as long as it's not equal to.
Oh, okay. Let's say not equal to.
So I'm going to generate my cave, and if it's not the exact number of rooms I'm looking for, I'm going to generate the cave again. So I'm going to keep randomly generating caves until I get a 7-room cave. Does this make sense? Because right now, driver says, create me a cave with 7 rooms. Before, that meant create me a cave with at least 7 rooms. Now we're going to say, create me a cave with exactly 7 rooms. So I have 13 moves remaining. So I should be exactly 7 rooms here. Oh, but I only have 2 treasures.
You got it. Yeah.
I got it on my last try. I literally found the last room on my last try. So it's tie goes to the runner. That was my first victory. Okay. So, what if I say I want a cave of 75 rooms? Seems to go pretty quick, right? So we can keep scaling it up, scaling it up, scaling it up. Okay. Now, what should happen when we get all the treasures?
It should be say winner.
Say winner and go on to a more difficult puzzle.
Next one.
Okay. All right. Now, let's take it back down to 7 here. Is there a way to represent our rooms? That is, can I display my cave? So let's say we were looking for a way to display the cave. How would we do that?
With creating new classes of cave.
New class of cave.
Kind of you move from one cave to another.
No. What I'm saying is let's say I wanted to write a method inside of cave called display. This guy displays a textual representation of the current cave. So I want a map. I want a map of the cave. How would I do that? So I currently have a cave. And I can traverse our cave, correct? And we can find treasure in our cave. But now I want to be able to display our cave, almost like pulling out a map and seeing an overhead view of our cave. So I might see something, text-based of course, that looks kind of like this. How could I represent this in text?
Yeah, we have to display every room with some number or some like signs so that it could display.
Okay. How would I display this in text? So here's a room. This room has 2 exits, 0, 1. Here's a room. This room has 1 exit, 1. Here's a room. This room has 0 exits. Here's a room. This room has 1 exit. Here's a room. This room has 0 exits. How would I textually display this? Could I do it with like periods?
Yeah, we can use lines.
So I could say dot, then, okay, you said I could use lines. Okay. Tell me more about that. How would you represent this using lines? Remember, we don't have graphics to work with. We need to do this all to the screen output.
Yeah, we can display the same thing. We can display box. Yeah, we can use square.
Well, we don't get squares. We don't have squares. We have text. We have things that look like this. This stuff. We have to display our map like that. So maybe our map looks like so maybe it's a period, and coming off of this guy was a couple of periods. Coming off of this guy was a period. Coming off this guy was a period. You do something like that. Similarly, you could have a, what does our cave look like? It looks like that. Okay, so that's 2. So maybe it's 2. Then 1, 1. Then 0, 0. So this is a room with 2 exits. This is a room with 1 exit. This is a room with 1 exit. This is a room with 0 exits and a room with 0 exits. That's another way you could represent it, right? What about keeping track of where we've been? Rather than mapping out all the places that we could go, what if we've mapped out all the places that we have gone? So we know at the very beginning I'm in the main room, correct? I'm in the main room here. We'll just do it as zeros. If I choose to go to exit 0, that's going to take me to the left. So there's either 0, 1, or 2 exits here. So I know if I have 1 up here, I could possibly have 3 here. For each of these, I could have up to 3. Correct?
Mm-hmm.
So this guy could have 3 exits. This guy could have 3 exits. This guy could have 3 exits. How do I display my exits?
Yeah, we can add the constructor for every room to display.
Okay. And how does a room display itself?
Yeah.
Think about like what we did with last semester with Connect 4 in the 535 class. We had a board display, correct? Yeah. Now we're looking at displaying something that's a tree structure. We want to be able to give the user some sort of hint of what this thing looks like or where you've been. How would we do it?
Yeah, we can add lines. We can use stars.
Okay, so let's say I'm going to use stars. Yeah, I mean, I'm not looking for random examples. I'm looking at how do I actually do it? I want to do this. How? Who knows about what?
Yeah. Cave knows.
My cave knows about the entrance. The entrance knows about his exits. This room knows about his exit. This room knows about his exit. This room knows about no exits. This room knows about no exits. They all know about the cave. Does this room know where in the cave he lives?
No.
Doesn't. In fact, he doesn't even know how to get to him, how to get to himself. So how would I draw this out? Well, we have an easy starting point, right? Entrance. No problem. Here, you want to use stars? 1 room. Circle look better. We're in the entrance. Display this room. Now, as soon as let's say I chose 0. So from a given room, 0 would be down to the left, 1 would be down, 2 would be down to the right. Correct?
Mm-hmm.
All right. So if I go to 0, I'll be there. From this room, if I go to 0, that's down and to the left. If I go to 1, that's right down. If I go to 2, that's down and to the right. That make sense? Can I keep track of where I've been? How would I keep track of it? What kind of structure would you keep track of this information in?
The link. Linking with each other.
Okay, that doesn't tell me much. Specifically, what kind of structure would I want to store this kind of data in? How big is my tree? Well, n-ary means that it's the number of children each node has, right? So it has n children. We know it's 0, 1, or 2 children. If we think about this guy, isn't it kind of a big grid? We don't take up all the grid, but isn't this a 2-dimensional array? How wide does it need to be? And how tall does it need to be? How many rows and how many columns?
Yeah, like we can use n number of rows and n number of columns. Like we don't know.
We need enough rows and we need enough columns. How do we figure it out?
Yeah, just we can increment the counts and we can display.
Well, increment what counts?
No,
Keep in mind, each room that gets created goes down to a farther depth, correct? Does each room know about its depth? Could each room know about its depth? So, if I'm a room, when a room gets created, it gets passed in the cave. Could it also get passed in a depth? Maybe we have a private int my depth. And we say this dot my depth is equal to depth. Now depth is the how many rows down we are. So when we first build our cave, we're going to pass it, when we create the entrance, we'll pass it the cave as well as you are at depth 0. That make sense? The very first guy is at depth 0. This guy's depth 0. This guy's depth 1, depth 2, depth 3, depth 4. That make sense? So a room knows its depth. When a room creates new rooms, what are the depths of these new rooms? If this particular room is spawning off new rooms underneath it, new exits, what's the depth of those exits?
It's the same as the other room.
No, exactly. Exactly what's the depth of of these exits? If this particular room is at depth, its exits will be at depth what? If this room's at depth 0, its one exit is at what depth?
That's 1.
1. If this exit is at depth 1, this guy's at depth what?
2.
2. If this guy's at depth 2, this guy's at depth what? So each of these exits is at depth what? This dot my depth plus 1. One more than whatever my depth is. That make sense? Okay. Now, just for the sake of interestingness, as a room is created, I'm going to have it print out its depth. So we'll see what the deepest is. Okay, so I saw 13. Oh my gosh. 37. Oh, remember we're creating these multiple times?
Yeah.
So yeah, we must have had a couple of big trees. Remember, we keep creating caves until we get the cave of the correct size? Right now we're creating a cave of size what?
7.
7?
Yeah.
Yeah. So those were all of our failed attempts. But we saw that depth is getting set, correct? Okay. So that'll tell me how many rows that I might need to have in a two-dimensional array. But how about how many columns? How wide does it need to be? When we create an exit, if we're at this top level, possible exits are here, here, here. What if I'm at this level? So this level has a width of 1. This level has a width of 3. This level has a width of 9. 3 for each of the 3.
Oh, okay. So next one would be
27. 3 for each of the 9. Does that make sense?
So this maximum at 10.
So how wide does my array need to be? It needs to be depth times. So depth is 0.
Times 3.
If depth is 1, 1 times 3 is 3. If depth is 2, we have 9. How did I get to 9?
Square.
This is 3 to the 0th power, 3 to the 1st power, 3 to the 2nd power. It's 3 to the depth power. That's how many columns we need. So in order to figure out what my grid needs to look like, I would figure out what my maximum depth is and create a two-dimensional array that is wide enough for that. So if my maximum depth is 3, my two-dimensional array would have to have a width of 9, 3, so this is 0, 1, 2, 3 to the 2 power of 2 is 9, right? Width of 9. So I would need 3 rows, 9 columns to represent all the possible configurations of this tree. Make sense?
Yeah, but we are not using 9 power in the tree, so it will be.
I know the maximum number of exits I can have is 3 for any room. Now, if this particular tree doesn't have an exit there,
56.
we would still need this width as a worst case. Remember, we're just trying to produce a map. So if we don't have an exit there, we know that we won't use these last 3 spots. Maybe they're underscores. Just like this guy is an underscore. So if my entire map looked like this, we might have a grid that is 3 by 9. So let me kind of draw this out for you. There's my top exit, top room. Now, inside here, let's say I have 2 rooms. Inside here, let's say this guy has 1 room. No room, no room. Next guy has 1 room. No, let's see, he has 2 rooms. Actually, let's see, he has 3 rooms. So now we have cave entrance that has 2 exits. This guy has 1 exit, which should live here. This guy has 3 exits. Here, here, and here. Because the other 2 exits from this guy are blank. That makes sense?
Mm-hmm.
Could this be a way that we could represent our cave? If we had a map that looks like this, does this tell us what a cave looks like? Ish. How can we build this? Well, we already know what? Can we get our max depth? We're already keeping track of depths, aren't we? Okay, how do we keep track of our depths?
Plus 1.
All right, well, I want to know what the maximum depth is.
Maximum depth.
We're going to do this. Inside of stats, I'm going to set moves left to 0, even though it doesn't matter. I'm going to create a private static int max depth. Start this off at 0. Make sure that resetting zeroes it out. And then what we're going to do is we're going to have a public static void set depth. And this guy's going to take an integer as a parameter. This integer is going to be called, this method is going to be called by every single room to set its depth. But we're only going to set the depth if the current depth is larger than the current max depth. So if depth is greater than max depth, then max depth is equal to depth. Otherwise, do nothing. That makes sense? Every single room is going to call this method, but only some of the rooms will actually modify the value of max depth. Because what do we ultimately want to do? We want to be able to ask stats, what was the max depth in our tree after the entire cave is built? And this guy will say, the max depth, that is the room that had the depth that was the largest out of all the rooms that called me, there might have been ties, is this guy. So we need to now give ourselves the ability, public static int get max depth. This guy will return max depth. Make sense? So now, every single time a room is being built, that room knows what its depth is. What am I going to do? I'm going to say stats dot set depth to this dot my depth. And that may or may not change max depth. But we'll try. That make sense? So after a cave has been created, when I get past this, notice we're resetting stats each time through. And resetting stats also resets max depth. Okay? So after we finally create a cave of the correct size, I'm going to do system.out.println. Max depth is stats.get max depth. And this should tell us what the maximum depth of the current cave is. Max depth is 3. Max depth is 4. Max depth is 4. 3, 3, 4.
You cannot make more than that.
Well, you potentially could. You
7.
could go all the way down one row. You can keep having, you know, one exit, one exit, one exit, one exit. You could have a depth of 6,
Oh, okay.
right? In a worst case, you could have a depth of 6.
It's gonna be all zeros.
Yep. All right, does this make sense?
Yep.
So now how, if my max depth is 4, for instance, what's my max width?
2. That's 16.
Well, it's 3 to the 4th power.
3 to the 4th power would be
81.
3 times 3 is, well, 3 to the 0th power is 1. 3 to the 1st power is 3. 3 to the 2nd power is 9. 3 to the 3rd power is 27. 3 to the 4th power is 27 times 3, which is what, 54, 64, 74, yeah, 81. Okay? So, given this, a cave is going to keep track of a 2-dimensional array. So we're going to have a char array. We're going to call this guy the map. Actually, we're going to create another class called map. This will actually make it easier.
okay.
Okay, because of the way we're going to have to plot it. So I'm going to create a new class. We're going to call this guy map. And map is going to keep track of a private char, 2-dimensional char array called, let's call this the grid. Public map int rows int cols. We're going to say the grid is equal to a new char array rows by cols. And then we want to go ahead and fill this grid up with underscores, because that's what we've kind of done here. We've represented the empty map as being a bunch of underscores. So we'll create a little for loop for int I is equal to 0. I is less than the grid dot length I plus plus for int j is equal to 0. J is less than the grid at bucket I dot length j plus plus. And then we'll say the grid at bucket I j is equal to the underscore. Okay? Then we'll create a little method in here, public void display, so a map can display itself. We'll steal this little for loop here. We'll print out every single column for every single row. So that'll kick it down a line. Okay, so if this was a depth 3, this would print out 9 underscores, followed by 9 underscores, followed by 9 underscores. Even though we know depth 0 only needs 1, we're still going to make it a big square for our map, because maps are square, right? But only some of the map is taken up. All right, so to display our map, we're going to go through all the rows, and for each row, we're going to go through all the columns. What will we do for that column? We'll display with a print, not a println, all the underscores, or all the things that are currently in our grid. Then after we finish off a certain row, we'll kick it down a line with a println. Okay? So inside cave, after we have our max depth, what we're going to go ahead and do is we're going to say a cave also keeps track of a private map called the map. And we'll say the map is equal to a new map. Map takes in rows and columns. The number of rows we're going to give this guy is stats.getMaxDepth. Number of columns is max depth to what power? 3 to the max depth power, rather. So we're going to say math.pow. This is how you can use the math library to take something to a power. What are we taking to a power? We're taking 3 to the stats.getMaxDepth power.
So we're using library of math there.
Yep. Let me minimize this here. And I want these to be doubles. So here, I'll just cast this to a double and it'll stop complaining. That's the end of that. Okay, we need one more. There we go. Actually, I don't think this needed to be a double. We just needed to tell it that it returns an int. Okay, because map takes an int as a parameter. Int rows, int columns. And math.pow actually returns a double. So we just cast it to an int. So this will create our map, and then just for completion's sake, we'll say the map.display, and this should show an empty map. That make sense? So we haven't put anything into the map yet. So there's our empty map. Okay? Now, we want to put stuff into the map. Well, how do I do that? Well, the very first room that should go into the map is the entrance. That is up at depth 0. If you're at depth 0, where do we start?
Yeah, from cave.
Well, in our map, where do we start in the map? The center. We're at the very center at the top.
Yeah.
Row 0 in the center of that. How do we get the center? Should be length divided by 2.
Yeah.
So as we're creating this, we're going to have a cave So we're going to teach our cave how to return the map. Why did we do that? Because all the rooms have access to the cave. We've already built that into it, correct? Okay, all the rooms have access to the cave. So now if I'm a room, and I'm being built right now, and I know my depth, I need to go ahead and add myself to the map. Makes reasonable enough sense, right? Okay, so we're going to say this dot actually, let me think about this. I'm going to do it at the top level first. When we first add something to our entrance, we want to build that initial room. We know that that initial room, when it first comes into creation, let me think about my map here. Let's do it on this one. So if right now my map is a bunch of underscores, That's my current map. And we're at depth 0. This guy currently has a length of 9, correct? In our little model here. I want my 0 to be at bucket what? 0, 1, 2, 3, 4.
And a 5.
Somewhere in there, right? Go either side of it. So this is 0, 1, 2, 3, 4. Actually, I'm going to do it right here. That'll be at bucket 4. Is that centered?
Mm-hmm.
There's 4 on either side, correct? And this is at bucket 0, 1, 2, 3, 4. So we're going to take the length minus 1 divided by 2. That gives us our center. Make sense?
Why we get minus 1?
Length is 9. 9 minus 1 is 8. Divided by 2 is 4. That's the bucket where our center will go.
Mm-hmm.
Okay? So we're going to teach map. Public void add room. So a room is going to add itself. Now we want rooms to be able to expose their depth. Make sense? So I'm going to write a method inside a room. Public int get depth. And this guy will return this dot my depth. Okay? So now every room knows how to tell other people about its depth. So if our map here is adding a room and we currently have the depth, couldn't we then ask that room to give us its depth? And won't that show us where it should be? All right. So let's make this work just for the first room. Well, let's see. We'll say int depth is equal to r dot get depth. Well, I don't even know why I just put it in a variable. If r dot get depth is equal to 0, we need to calculate center. We're going to say center is equal to this dot the grid at position r dot get depth dot length. That's the number of columns. We want to take that number of columns and we want to subtract 1 from it. And then we want to divide it by 2. And that will give us the center of that row. That make sense? That'll give me the center of that row. And then what we'll do is we'll say this dot the grid at r dot get depth center is equal to, just for right now, a 0. Okay? So every room will call this method, but only the one that's at depth 0 will actually get added to the map. Kind of our simple case. So when we display our map, what we should see is an empty map except for our very center room at the top. Because that's the only guy that actually gets added to the room, or that actually gets added to the map. Every room will try to add themselves to the map, but he's the only one that actually gets added to the map. Okay, so that's how a map works. We'll come into room now.
That's very wide.
So right here, we're going to say this, I'm sorry. Yeah, this dot, the cave dot, get map dot, add room, this.
Why we
Okay, kind of an interesting statement. Who is this?
This is a cave.
No, 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 no. What class am I in right now?
Out in the room.
Okay, what's this?
It's the current room.
Yeah, it's this room. It's how this particular room refers to themselves. So this room is passing. So this is, we're saying, cave, give me the map. Then I want to add a room to the map. What room? Myself. That's what that line says. That make sense? Okay. So that'll add this room to the map. Every single room that gets created is going to try to do this. But only the room at depth 0 is actually going to get added to the map right now. So that when we display our map out here in cave, we should just see an empty map with a single 0 in the center of the top row. Oh, nice, perfect. Cave 11. Room real quick. Oh, I'm trying to use the cave before I set the cave. Probably don't want to have this line this high up here. In fact, why don't we put this line here at the bottom after we've built out this room. Get map. Oh, interesting. The map doesn't exist until after the cave has been built. So rooms are being created. They are trying to call upon this map. Where's a room? They're trying to call upon this map here, but that map does not get created until after the cave has been built. So we have a chicken or the egg problem. The map doesn't exist yet, so a room cannot add themselves to the map at the time it's being created. So what we'll have to do, we can't do this in the constructor. That's the punchline here. We cannot do this in the constructor. Instead, what we'll have to do, and you understand, we can't do it in the constructor because the map doesn't exist when we're building a room. Map gets built here. So after this is done, before we display it, at this point the map exists and the cave exists. So now we want to fill the map up with rooms. That's when we need to add the map dot add room this dot entrance. So we'll add the entrance to the map then. And we'll let it grow from there. This will work. Okay? So after we've built our entire cave, the cave knows where the entrance is. After we've built the entire cave, what will we do? We will create the map of the correct size based on the max depth and the max width. Then we'll add the entrance to the map. Then we'll display our map. And this gives us the 0 in the center at the top.
Okay.
That makes sense? The reason we were getting that null pointer exception is we were trying to add stuff to a map that did not exist. Okay, so now we're in map. A map just got the room. If the depth is 0, we're going to add the, well, if the depth is 0, we're going to add the room. Otherwise, what are we going to do? Every room, well, let's think about this for a second. Yeah, this will work. If I'm at 0, we're going to go to the center, and then what are we going to do? I add myself. Now I need to add my children. Does that make sense? How many times do we want to do this? We want to do this max depth number of times. So this is what we're going to do. Center is always going to be this. First time through, start. We'll start at the center. Right now my grid looks like this. So start and center are both right here. Okay? For int I is equal to 0, I is less than this dot the grid dot length. That is the number of rows. We know that that number of rows is identical to the maximum depth. Correct? We know that that's a fact. I++. The first time through, start will be the same as center. At row 1, though, so start starts here the first time through, but start starts one left of that, the second one. What I mean by that is this is start for the first row, this is start for the second row. This is start for the third row. Does that make sense? Mm-hmm. So we need to keep track of not only where center is, but where start is. Start is relative to center. So start went from 0 went from the center to the center minus 1 to the center minus 3. Zero, 1, 3. Next time down, it would be 9. Okay? So let's do it this way. We're going to treat the first room as the starting point. And we're going to treat it as a special case. So we're going to say this dot, the grid, at bucket 0, center is equal to R0. That takes care of the position of the entrance. Now, for all of the rest of these things, start is going to start off as 1. Okay? That is an offset off of center. So, for each row, right now we're in row 1. I only want to put a 0 at bucket if this guy looks like this. So right now I'm at row 1 and it looks like this. Okay? But start is right here. If this guy, the room right above me, if that guy had a exit at 0, what do I want to do? I want to put a 0. If that guy had an exit at 1, I want to put a 0. If that guy had an exit at 2, I want to put a 0. Then we drop down to the next level. Start is off the beginning. Previous dude is this guy. That makes sense? Previous dude is this guy. Previous dude is this guy. So if I'm on this level, I'll put a 0, 0, 0 here only if this guy had 3 exits. I'll put a 0, 0, 0 here only if this guy had 3 exits. And I'll put a 0, 0, 0 here only if this guy had 3 exits. Does that make sense? So we need to go across all of these rooms. So when I'm on row 1, I need to deal with all of the exits for the room in row 0. When I'm in row 2, I need to deal with all of the exits for the rooms in row 1 to display them. So for each of these exits, I'm going to start building out my zeros. Okay? So I need to get this collection of exits. This collection of exits is what? This guy's exits. This collection of exits is what? This guy's exits plus this guy's exits plus this guy's exits. So I need to put them all together. Okay? So this is what we need to do. We're going to teach rooms. Rooms have a private linked list called the exits. We need to be able to ask a room for its exits. So let's do it right before get input. Public linked list of room. Get exits. Will return the exits. Okay? The exits is a collection of rooms. Now, inside of map, I'm going to set my initial exits. So I'm going to say linked list of rooms. Let's call this guy, call this cur rooms. Think about this. Let's call it next exits. This guy will be a new linked list of room. So this guy's a linked list capable of holding rooms. And he's going to keep track of my next exits. Now, initially, my next exits are going to be this particular room's exits. That make sense? So, in order to do that, because before this for loop, I know I need to import java.util. Before this for loop, I know that I'm only dealing with the entrance. So at most, I'll have 3 exits. That make sense? So I'm going to go ahead and I'm going to copy those guys into next exits. I don't want to set the two things to each other because I'm going to move them. Okay? So I'm going to say for, actually I can do this as a for each loop. For room R in, I can't say room R, room cur room in R dot get exits. Let me call it exit. For room exit in R dot get exits, I'm going to say next exits dot add exit. So this guy will build up that list of exits. Okay? So what did I do the very first time through? Very first time through, this room, I added them to the map, and then I said, okay, let's load up a linked list called next exits with all of these rooms. That is this guy's exits. Okay? I know that these are the next guys I have to deal with. But before I deal with their children, I need to add them to the map. Okay? Now I know that I'm going to be starting at this position right here. How many exits are going to be in this thing?
9.
Well, potentially 3, potentially 2, potentially 1. How many zeros do I put there? Well, it depends. Depends on how many exits the parent has. If I'm at the root node, and the root node currently has 0 exits, I won't put anything there. If he has 1 exit, I'll put a 0 just to the left. 2 exits, I'll put a 0, 0. 3 exits, I'll put a 0, 0, 0. So it's pretty hard-coded as to what I will put in for a representation in the map. So actually, do I even need to deal with the next exits? I might not even have to. Because I could just deal with the numbers. Actually, I can. Yeah. Let's just do that. So this says if I'm the starting room, go ahead and put a 0. Now let's start dealing with my children. Okay? My children are room R. So I'm going to say, we know we're at depth 1 currently. So inside of here, I'm going to say, we don't need start to have a value yet. Right here, start is going to have a value of center minus oh wait, we did it already to begin with. Start already has a value 1. At the very end, start is going to have a value of center minus start times 3. Correct. But that'll happen at the very end of that for loop. Start is currently at the right spot because I started off at 1. That is the first time it's at 1. The next time first time it's 1 off the center. Okay? Second time it's going to be an additional 3 off the center. So that should actually be center minus 1. That's where the initial start should be. The next time around, started off at, that's 4, should be 3, 1 less than it, then 3 less than that. Start minus equals 3. That's what it'll be. So each time it'll zone out by 3. No, that's not right either. It's not right either. This is start minus 3 to the 0th power, 3 to the 1st power. Okay. Okay, start minus Kerpow. Each time through we'll say Kerpow times equals 3. It'd be another multiple of 3. So then start will be equal to Kerpow. So the first time it's 1 off of center, the next time it's 3 off of center, the next time it's 9 off of center, the next time it's 27 off of center. Does that make sense? And now obviously our maps can get pretty huge here. So our little mapping thing is only going to work out reasonably well for us for very small maps. So this is more just an algorithm exercise. Not something that we're really going to find useful. Okay? Well, not useful in a text-based situation, because we already saw that even with this a depth of 4, our map is huge. Okay, so the current place that I'm going to put stuff, I'm going to be starting at position start. So for each exit, I'm going to have this room called cur room, started off at R. For each exit in cur room dot get exits, I'm going to do something. What am I going to do? I'm going to say this dot the grid at bucket row I column start equals a 0. Then I'll say start plus plus. So that should fill in all the exits related to the room right above that. Okay, at our current level. Then, what do? Kerpow times equals 3. Move down to the next row. What will we do the next time through? The next time through, we'll do that exact same algorithm for this room, then this room, then this room. First time through, we did it for this room. This guy had 3 exits. Then we did it for this guy's potential 3 exits, this guy's potential 3 exits, this guy's potential 3 exits. Next time, we'll do it for this guy's potential 3 exits, this guy's potential 3 exits, this guy's potential 3 exits, so on and so forth. Okay, so this is what we do for each exit in the current row. So for each room in the current row and for each exit in that cur room. So the first time through, cur room starts off here, then cur room becomes this, then cur room becomes this. Down here, cur room would start off here, then 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 here. So the map would end up growing itself. Kind of makes sense where we're going with this? It's not going to be that useful for us, so we won't actually finish it. We're running out of time anyways, and it's not going to be useful for a homework assignment for that. But do you kind of understand where we're going?
Mm-hmm.
We're letting the map grow itself. Okay? By asking each room to deal with its own exits. Okay. So that is how we might add a room to our map. For right now, I guess just to, I want to make this as non-confusing as possible. Let's go in here to, let's get rid of the map from our cave. We'll say caves don't have maps. So then we won't deal with that there. A cave also will not be able to return a map anymore. And a cave cannot display itself. Okay. Then I'm going to go ahead and I'm going to delete map. That way you don't have this extra class sitting in your source code that I gave you, confusing you as to what you need to do for your homework. You know what I'm saying? I just want to give you what you need for your homework.
I know, but you deleted this much work.
No. I mean, we learned about an algorithm. We thought about how we can do this. So, the point is that it's not something that would be very usable in a textual representation, but if we had to do it,
Okay.
What we just understood is that we're going to let the map grow itself. So that's an algorithm where we allowed each room to deal with its own exits in terms of displaying the map. Okay, so right now, driver creates a cave, size 7. Then we play. Shows us number of moves remaining, blah, blah, blah. So I can go 0, 0, 0, 0. Begin. Oh, I have two treasures left. Okay, 1, 0, 1. 0, 0, 0.
You got all treasures.
Oh, I did. Very last try. Man, I can only win, barely running out.
Oh, there was no treasure.
There was just in the very last one I got. Then it showed me the new room. Okay, so let's talk about our homework assignments. Just so I don't forget here, let me go into... This is crawler, right? Isn't this the guy we were just working on?
Yep.
Okay. All right. So Unit 2, homework number 4. Extend our crawler program, see attached, such that the game goes on until a user finally loses. The game should start with a map of size 4, then increases by 2 each time. So the first map is size 4, the next is 6, 8, and so on. Okay?
So if you win,
If you beat the first map, size 4 map, then congratulations, blah, blah, blah. It pops up the size 6 map. New set of moves, all that stuff, you start over. That make sense? Okay. Winning a cave means that you found all of the treasure within the number of moves available. Okay? For each cave, a new set of stats should be established.
Have to do something with stats.
So that a new set of moves, well, a new set of stats should be established. You should be able to accomplish this with our reset method. Stats knows how to reset itself. Make sense?
Mm-hmm.
Okay, so you'll kind of have to see how stats works with creation of caves and all that stuff. Okay. Your program should ultimately display the level that the user was on when they finally lost. That makes sense? So you're basically taking all the code we currently have and just wrapping it in a little more game mode. Okay? This shouldn't be overly difficult, except you're having to work with a relatively large amount of code. Okay? You're not actually having to do that much logic. All right, let me attach the code, and then we'll talk about your paper. Okay, there's the code. Okay, paper this week is actually going to be really cool. At least I hope it's going to be really cool. Report number 4. Write a 2 to 3 page paper discussing Bitcoins.
Oh, I was thinking to research about that.
Okay? What are they? Who made them?
Huh.
How long have they been around?
That's kick-ass.
What is Bitcoin mining? Really cool thing. In your opinion, will Bitcoins stick around? Why or why not? Make sense? How many of you have looked into Bitcoins before?
I heard the news a lot.
So like you've heard the buzz of Bitcoins, but you don't know that much about them?
No.
It's quite fascinating, actually. I think you'll like this. So that should be kind of a fun paper, and you should not have any problem filling 2 to 3 pages with that. There's probably enough articles that came out this week to give you information for that. All right, questions about that? All right, I will see everybody next Monday.
We do the Easter Monday.
I don't think so, do we?
Easter is Sunday.
Right, Easter Sunday. I mean, if the school's closed, then we don't, but I'm pretty sure the school's open that day.
Are you coming?
Well, if we're supposed to have a class, I'll be here. So, I mean, if we skip class, then we just go 1 week later. So I guess I'd say this. If any of you seriously have like Easter plans where you're going to be out of town, you could skip class and watch the video. I would encourage you to come to class, but I don't want you to come home from your family or something a day early just to come to class, since I videotape it. Make sense? So I will be here. is the punchline. All right. I will see everybody next Monday, or I'll see you when I see you.